Hello. So we are going to be talking about the slope formula today. And the idea is how do we find slope when we don't have a graph is ultimately where we're going to go to. But starting out with this, we have this particular graph, we have this line, and I just want to remind you that if we wanted to find slope for this line, we have a strategy that says we can draw in that slope triangle, right, where we connect two nice points, and then from that triangle we can then count the difference on both sides. So we would see that on the bottom right here we would have a 2, and then going up and down 1, 2, 3, 4, 5, 6 would be a 6. And we know that in our slope formula, or M, it's going to be change in y over change in x. And so if we look at those values right there, the change in y would be 6, the change in x would be 2, and so we would get a final slope of 3. And that would be correct. And what I want to highlight right here is in this case we had the graph so that we could count the squares. But here's where I want you to think about where this 6 comes from. That 6 is coming from the 7 take away the 1. If you look at those two values right there, this 6 is coming from the fact that 7 minus 1 is 6. We're subtracting the two y values in order to get our 6. It's the same for our 2 right here. This 2 is coming from the x coordinates and is coming from 2 minus 0 equals 2. So in other words, we can use this idea of this subtraction step where we can figure out how long each side will be of our triangle without ever having to graph it. And so with that, we introduce the formal slope formula. Remember that our slope variable is m, and our formula says y2 minus y1. I totally wrote that wrong. Okay, that should be a y1. But I'm just going to roll with it because, hey, I'm already a couple minutes into the video. So we've got y2 minus y1 all over x2 minus x1. So we're going to use that to tackle this first problem right here. And so the approach I want you to use is this. I'm going to start off and I'm going to recognize that I have a first ordered pair x and y, and it is my first ordered pair, so it gets those little ones. I've got a second ordered pair, x and y, and because it's my second ordered pair, it gets the little 2's. And so I've now labeled all 4 of my points, and now what I need to do is take my values and plug them into my formula. So we have that slope is going to have this division bar, and it's going to have subtraction on top and subtraction on bottom. So I'm going to start by writing that every time. And now all I have to do is plug in the numbers where they go. So right here, the first number I have is y2. So in the first position, I'm going to have the number 15. Second position I have right here is y1. So I jump over to y1, which would be the number 5. Second row, I've got x2. x2 is the number 6. And then finally x1, which is going to be this number 2. So now that I've taken my 4 numbers and I've plugged them in, all I have to do is simplify. So going straight across, 15 take away 5 is 10. 6 take away 2 is 4. And putting that together, we could simplify that fraction on down by taking a 2 out, right? Divide the top by 2, divide the bottom by 2, and we get a simplified answer of 5 over 2. Even if you had just left it as 10 over 4, we would still take that right now, but just realize that since we're dealing with fractions, we can simplify our answers. Similarly, second one down here, I'm going to do the same thing. We want to use our slope formula. I'm going to throw in my subtraction sign because it's always subtraction. And then the trick this time is you'll notice that in ordered pairs we've got some negative signs. So here's where we jump in. We start with y2 as our initial, oh, I need to take a step back. I didn't label my points, did I? So I'm going to come back to our problem right here, and I'm going to say I've got a first point xy. It is a first point, so they get 1s. I've got a second point xy. It is a second point, so they get 2s. I'm going to take those values right there, and now I'm going to plug them in. So starting off, we've got y2 is our first position, and y2 in our problem is this number 5. I then go over to y1, because y1 is the second value, and y1, keep the negative sign, will be a -4. Okay. Second row, I start off and I need an x2. So when I come down here, x2 says that it should be a -1. And then finally, to finish out my formula, I need x1. So if I come over to x1, I see that it is the number 3. So now I can go through and I can simplify this on down. I want to remind you, you have full permission to use a calculator to punch this in. Do be careful with the negative signs. That's probably the number one mistake. Students will put the numbers in the right spot, but then either forget to include the negative sign or forget to include it in the calculation. But hopefully you remember that anytime you subtract a negative, it becomes plus a positive. So our numerator, or top number, is now 5 plus 4, which is 9. And then our denominator is going to be -1 minus 3, which if you know, awesome, or if you plug it in, that's fine, will become a -4. And that won't simplify at all because 4 breaks down into 2, but 2 doesn't go into 9. So that would be our final answer. So that's just a little overview of finding slope given two